I want to finish up with this Kenwood 5500 today and tell you about some things that you need to know in order to get an lme49860 into this. I guess there's really two ways to go about this. You could obviously make up one of these little adapters here and maybe insert it on the front board on the component side and do it that way. This is actually an 8-pin now. I think that's a 7-pin. It's been a while since I messed with this Kenwood. So you could certainly do that, make up these little adapters. But I did it a little bit differently. I just mounted mine on the back of the board, and there's really no difference between the two overall. So all I did was just solder mine down onto a piece of perf board, and then take a piece of double-sided tape, foam, and put it underneath the perf board. And then I think I eventually ended up putting some adhesive on it at some point in time. There was a little bit of finagling that around to get it into position with where it should be in respect to the existing pins that were on the board. So you had to find a sweet spot there in order to keep the lead lengths as short as possible, which is something I'm a little crazy about. That's what I ended up with there. The LME does very good in this amp. It probably does better in this amp than any other amp I've ever put it into. And there's a couple reasons for that. This isn't a direct coupled amplifier, so we do have some coupling caps and some other differences that make it work better in this. But it's a fantastic improvement over the existing op amp that was in there, which I guess that was made by Toshiba 7136P, I think it was, if my memory's right. And it's really not hard to wire in there, but there's some other things here that you need to focus on before you even think about doing something like that, and I'll get to them here in a second. Now, before I go down this road I'm about to go down, I just wanted to tell you that this is an optional thing. This isn't 100% carved in stone you need to do this. But I did it for many reasons, and it's a good thing to do. I would highly recommend taking care of these things here before you just stick the op amp in there. You can do that and you won't have a problem, because I ran it like that for quite a while. Actually, I just had to look recently, because I never even looked up the specs on the 7136 several years ago. It really didn't matter to me what the specs were, but now that I just recently seen them, I see that chip was meant to run on plus and minus 20. The distortion spec on it is, of course, what I would have expected. It's pretty high, probably in the audible range. At like, well, maybe not the audible range, but I think it was like 0.1%. So of course we know the LME will run up to plus and minus 22.5 is the absolute max, so you have a 45 volt window there to run on. So here's what I'd recommend doing if you want to put one of those high performance op amps in there, even if it's not a 49860. I would recommend putting another regulator board in here, and there's 200 milliamp regulators here, LM317 on the bottom and an LM337 on the top, set at 20 volts through this 240 and this 3.6K on the adjust pin to ground. There's two 1 mic tantalums and they are just out in, they are on the out, and there's 2.1s on the in. You technically don't need them there, but I always use them. You can get away with doing away with them in this unit if you really truly wanted to, but if you're going to go through the trouble to do all this, it only makes sense to go through the trouble and do it all right. So what we want to do here, looking at your power supply pins, looking at the first 3 pins here, there is an orange and a white wire, which is your plus and minus power supply, that comes over here and hits the amp board, and that's what powers the op amp. The original colors were orange and white. Orange being your plus volt and minus, or white being your minus volt, which the white was on pin 1 and the orange was on pin 3. So I left these colors the same as they originally were, just you know, to avoid confusion down the road for somebody. So what we want to do is take those 2 wires that are jumped across here from pin 1 and pin 3 over onto these 2 points, and we want to take them off of there so we can isolate the power supply lines to the chip. And then what we want to do is build our little regulator board here and just merely insert it back into the circuit. That's all there is to it. So that's all we got there. Let's see if I can hold this at an angle where it looks the best. We just have an LM317 and an LM337 set up as a 20 volt regulator. No big science to it. Okay, here's the main reason why I suggest that you put the regulators in. The way these were wired originally, if you look at it in these simple terms here, Kenwood had 1 voltage regulator, and it was decoupled 2 times over from the power supply voltage. When you put that voltage new regulator in there, you're still going to be 2 times decoupled from the power supply, but you're going to be 2 times voltage regulated. And just I don't know what I spilled on this, who knows. Let's see if I can even get this in a way that you can just see what I mean here. Forgive the sloppiness. So we just had our power supply voltage setting here coming down, hitting our zener diode. So we have decoupling through that resistor and that cap combination, and then we're decoupling again through another resistor cap combination to power the op amp, where once you insert the voltage regulator in there, you're decoupled once through here and then you're decoupled again. But not only do you have a 24 volt regulator, now you got a 20 volt regulator that has very excellent line and load regulation to it. So that's why it's a good idea to do that. Just a little word of advice here. I'm sure everybody's ran into this just the same as me. This is actually bus board, and I don't mean to tear anybody up over this, but I see this bad stuff out there all the time, and just a little warning: when you build something on a bus board, don't ever plan on getting it apart again, because you're never going to suck the solder out of those eyelets. Anything double plated with feed through eyelets is just going to be a disaster. So I didn't even want to put this bus board in here, but that was all I had on hand, so I used it. But what I'm getting at is this: when you put these voltage regulators on there, it's probably a good idea you don't pull the leads through the board and then solder them through. So I just soldered the eyelets through, and I just soldered the voltage regulators on top. That way, if I ever need to change one for some reason, I can get the blasted thing off the board. Now, as far as the power supply goes, we're going to have to make a couple modifications on the power supply board here. Nothing major. It's pretty simple. probably only take you a couple minutes to do. The zener diodes are actually down here behind the filter caps, where it's just a little bit tricky to get to. I found the best way to do this is, since you can't get an iron and a desoldering pump down on this side of the board, at least you can get an iron. So just take a pair of hemostats, preferably a pair of curved ones, I think is going to be the easiest, and reach down in there and grab a hold of one of those zener legs and lock the hemostats on it, and then just pull your iron around and hit it, and just pull them out one leg at a time until you get the zeners off the board, and then just solder wick this side, and then getting them in. I don't think I had any trouble really fishing them back in there and getting them through. They're brand new zeners that I put in anyway, so I had long leads, and that always helps. When you put them zeners in there, stand them up on some, looks like about 18 gauge Teflon tubing. This will go over the zener leg. Stand them up off the board like 3/8 of an inch. It's not a necessity that you do that, it's just good construction practice, you know, because otherwise you're digging carbon out of a board. If you were to repair it, you'd have to sit there and scrape it all out with an X-Acto knife and epoxy it back in, at least if you're in the board repairing business, which I've done before, and it's never fun to scrape out big burn holes of fiberglass. So it's just good to set them up off the board. That way, if they ever short, and that would be about the only failure they would ever have, is a dead short, when they burn in two, at least the circuit board isn't all torched up. So we want to get those two zeners out of there. They're the only two zeners that are on the back side of the caps. There's only one other zener on the board down here. So there's really no chance of anything going wrong there unless you stick a zener in backwards, which can happen to anybody. They're actually should be labeled on the board as DK4, DK5. Well, labeled on the schematic anyway as DK4 and DK5. Probably not labeled on the board as that. At least not the DK anyway. Probably just D4 and D5 is what they labeled them as. So once we get them out of there, we want to pop in, if you have some 24 volt 5 watts, 1N5359s. If you got some 5 watts, that'll be fine. If you got some 2 watts, we can get away with that too. That would be alright. So the next step is we want to get these hogging resistors out of here. They were originally 560 ohms. They're labeled as R2 and R3 on the board, and they are on the schematic RK2 and RK3. They were 562 watts. I got 475 watts in there, and the reason I got a 5 watts is because it's extremely hard to get parts these days. So I had to take what I could get. I actually wanted something slightly below 470, but I couldn't even get that in this craziness. So ideally, you don't want 5 watts. If you can avoid that, don't do that. Make sure they're metal oxide. Make sure they're flame proof. A 2 watt would be ideal. A 3 watt would be pretty ideal. But you don't have to get crazy and stick a 5 in there. So here's just a little bit of the simple math we use to determine that. Working with electronics is great as long as you have a known, which I guess you always have a known. And our known was just our power supply voltage. Of course, we have another known, which is a zener diode voltage. So all we did was just subtract 24 from our 44 volts. Come up with 20 volts dropped across this. We know that we want to give that op amp at least 12.5 milliamps. If we say, you know, we'll give this direction 15 or 20 milliamps, that's fine too. We know we want to keep this zener happy, And he's going to be pretty happy there because he's getting 30 milliamps. So we got 42.5 flowing down through here. If we got 30 milliamps across the 24 volt zener, we got 1 watt of dissipation there. And we got 20 volts dropped across that resistor. So we know we got 850 milliwatts there. So that's what I said. If you want to put a 2 watt in there, that's great, a 2 or a 3, but I wouldn't put a 5 in there unless you have to. As far as using the 5 watt zener here, you could downsize that to a 2 and that would be plenty. So there's a lot of flexibility here. So backing up to the voltage regulator on the back side of the board, here's what you're going to need. Maybe I'm being redundant, I don't know. You're going to need two 3.6Ks, two 240 ohm, an lme49860 /NOPB is what I used, an lme49860 LBZRAG is what I used, because that's what was available again. Okay, jumping ahead. I hope I was clear on everything there with what we want to accomplish with just simply hooking our regulator back in place for the existing wires that were there. I'm hoping that was crystal clear to you. Moving on to the front board here, there's going to be some things that we're going to want to get off the front board. And it looks like we are going to be on the amp board. What is labeled on the schematic as RI17, RI18. They are both 120K resistors, and they're going to need to come out of there. CI8 and CI7 look like 5 picofarad, and they're going to have to come out of there. CI6 and CI7, 99.9% are 47s, and they're going to need to come out of there. They are all going to be jammed right around those two 7136P op amps. They're going to be, actually those caps are going to be right on the pins themselves, or right on the pads to the pins. So they'll all be right there. So you got R17, R18, C8, C7, C6. What did I do here? I just realized this. I got a duplicate somehow. CI8, CI7, CI6. I'm just wondering if that wasn't supposed to be CI5. I'm gonna have to double check that here quick.